I hope you all are healthy and staying safe. My name is Mahima Suryavanshi, and I am an alumni of School of Planning and Architecture, Delhi. As we all know, that the COVID-19 pandemic has affected major infrastructure projects in India and rest parts of the world. Over 2 dozen metro and urban railway projects are currently under construction stage in India. Out of those, some are facing major issues, and some projects have been faced by combating the challenges induced by this pandemic. So, there are many reasons behind it. Urban Transport News has introduced this webinar series on this interactive platform to keep information live. So, our today's topic is role of nanotechnology in smart urban transportation future of mobility. Dr. Amudhan Valvan, Independent Director, Metropolitan Transport Corporation. Mr. Keshav Mishra, Vice President,
I think
GR
Mahima
Infrastructure.
lost her connection.
Before we get started, I would like you to inform that if you have any questions during the discussion, please type them into the question box. I'll bring them up during the presentation, and we will also have a short question answer session at the end. It would be very helpful if if the presented may present the presentation in PDF form. Now, without a further ado, we will turn over to Mr. Saurabh Choudhary. Over to you, sir.
Yeah, good afternoon, everyone. First of all, I would like to thank Mr. Vinod Shah, Himani, Keshavji, and everyone here who has invited me for the small little presentation about the role of nanotechnology. So today's topic for me is role of nanotechnology in smart urban transportation, future of mobility. So small brief about me. I'm Saurabh Choudhary, the founder and CEO of BizSpan. I've studied nanotechnology from TU Chemnitz, Germany, and then I've worked widely in the field of nanotechnology with Fraunhofer NAS Germany, and then Riken Japan, and then Whole Center Netherlands, then in Indonesia, and now a consulting firm from last 3 years who is widely working into two sectors. One is market entry consulting, and one is for the Indian clients, we help them in business innovation, development, and strategy consulting, and expand their business within India and in Southeast Asia. For non-Indian companies, we mostly help in their market entry, making their strategy, their development in Indian market, in their policy and regulations. So we have been working in India from last 3 years, and we have successful clients from various sectors like chemical, nanotechnology, edtech, engineering, FMCG, safety, environment, social sector, pharma. So we have a good team who are widely working in these sections. And we have clients like UNDP, Stockholm International Water Institute, and some more renowned clients. So today I got a good opportunity to speak on the role of nanotechnology in the urban transportation, or the new innovation in the transportation. What would be the role of nanotechnology? So for that, I have chosen some of the topics. So the content would be nanotechnology. First, a brief introduction on nanotechnology, then challenges in urban transportation, and then nanotechnology, future of mobility, the complete application over that. And then I'll conclude it because I already took so much time in this technical grudges. So I'll try to finish it as soon as possible. Yeah, so a small description on nanotechnology. So anything which is 10 to the power -9 meter, which is like 1 nanometer, that comes under material comes under the section of nanometer. So if I'll in common layman term like our hair, 1 nanometer is like 1,000 times thinner than our hair, the human hair. So because of that, there are unique physical and chemical properties at nano size. It affects the photocatalyst, optical sensitivity, and mechanical strength of that body or that material. And because of it impacts those properties at so minor level, at the so nano level, that enhance the mechanical properties. Its application is in energy storage and the sensors, which can be widely used. These variation of the properties can be used in the many application at the big level. So I'll tell you briefly what would be the advantage of nanotechnology in the common world. Apart from the transport, I'll give you a brief introduction. It helps in promoting the renewable energy. It extends the limit of electronics. That's the widely I have been working for. Like it helps you in different varieties of electronics, like in touch sensors, in MEMS, developments of many sensors, biosensors. It also allows a more effective medicine. Like one of our teammates is working on the treatment for cancers with the help of gold nanoparticles. So it allows more effective medicines. Urban transportation, which we will be discussing today. It also detects the presence of pathogens in our food. One of our associate company is working. I'll give you an example, which is working on packaging material, which can indicates how old is the food and how much pathogens are already contained in that food. That will explain, the indicator will explain you. The smart textile. So I'll give you example of smart textiles. Soon, right now we have cricket match and we have the logos everywhere for the brandings. So soon we may have the t-shirts for the sportsmen, which will have the screen, which will be revolving with the advertisement. So it would be flat screen, flexible screen, and the transparent screens. It helps in wastewater and air purification, and numbers are still increasing. The application, it helps in civil engineering, healthcare, and many more application, which is like still growing and more to be innovate now. So, coming to the urban transportation, the challenges are strength and durability performance of the body of the transportation material, let's say coach of the train or let's say automobile bodies, the coating, sustainability of coatings, vehicle safety, cost and bulky radio frequency transmission, bulky equipments and systems, and non-environment friendly. So now we'll see how these things are overcome by the help of nanotechnology. So giving you a brief description, like nanotechnology can help in improve mechanical properties by coating lighter. It can give us lighter and robust body, advanced sensors and other parts. Innovative photonic and nano devices can be developed with the help of advanced nanomaterials. So in India, there is only one company. They are our client, Nano Orbital, which you can see the logo in my presentations. They are working on advanced materials, producing of silver nanowires and other advanced materials. That's the probably only one in companies in India, and they are our client of BizSpan, and we are helping them in their business development and the technical part. So more of the materials we will discuss here will somehow is developed by Nano Orbital in India. So, in generic terms, in automobiles, you can see nowadays we have a modern, ultra-modern automobiles which have different inclusions of nanomaterials, which can be seen in the pictures. Like we will discuss about all these applications slowly in further slides. But in the pictures of advanced car, you can see there are heat shielding, glazing polymers, which is helping in refraction and advanced terms of reflection and diffractions. In fuel cells, then the paintings, advanced in nano paintings, then the engine body. There are many advancements which can be done in the nanomaterial sides, in the advanced material side, and which is being done in the advanced automobiles and the cars, which can be implemented in the trains and the rails, which we will discuss further how it can be done. So the first application we would like to discuss about was let's say, for example, if we take the rail body, the coach, which can be more lighter and robust. So one of our research colleague in RWTH Aachen, Germany, they have been working on this robust body and light body train coaches, and they have used a carbon nanomer with the ceramic material, which is like inorganic polymer based composite, which is like fiber based, and they find it an ideal candidate for the passive protection system. Their basic properties was light, non-flammable, non-smoke emitter, entirely fireproof, temperature stability at high temperature, high viscosity, and better mechanical properties can be gained by those carbon and ceramic material. So they named that material as ASHT material. And further, they did some practical experiments on those material, which I can show you with some of the graphs, like how they achieved it as a lighter and robust and very good material for the manufacturing of the coach and for the rails. So what they did is like they give a certain temperature to that material, ASHT, and at 180 degrees Celsius, they found that weight loss is just 2.5%. At 1000 degrees Celsius, they found there is a linear degradation in the weight that is up to 1200 degrees Celsius. It was just the weight loss of 8%. And they did it for 15 minutes. Till 15 minutes, the coach was not burned. After 15 minutes, when the inner and the maximum temperature for the inner body was 250 degrees Celsius. So you can see by this graph. So the y-axis is the second part, like till 15 minutes, when it reaches till the transition temperature, glass transition temperature for the ASHT, and then it was a linear curve here. And after 15 minutes, they starts burning. So you can see that in 15 minutes, if it's not get burned, these bodies can save lots of life in the major rail mishaps or everything which we see in the daily life. So our research colleagues has also compared these bodies, ASHT, with different bodies which are used in the railways nowadays: the steel alloy, cast iron alloy, nickel alloy, titanium alloy, aluminum alloy, and then the last, the ASHT composite. So you can see the Young's models is that the excellent. So the Young's model is like at what temperature the body can be bent or stretched. So you can see that ASHT composite has the best Young's modulus, excellent tensile strength, density is the least, and the linear coefficient, temperature coefficient is also at its best, the excellent linear temperature coefficient, and the thermal conductivity is also excellent for this ASHT composite. So it was proved that if these material is used for the coach manufacturing in the railways, that can definitely reduce the weight by 20-30%, and it will also cause a lower energy consumption. And the carbon dioxide reduction will be up to 5% if these coaches are used. So in fact, Indian manufacturing units are also trying to make more lighter coach than the LHBs. So I think some of the manufacturing units are also working on these type of ASHT materials to manufacture the lighter coaches. So now second thing is like after the coach is made, like we want to have an advanced material for the nano coatings. So here in the A part you will see, so there are many drawbacks for the current nano coatings which we do. The key problem with the conventional painting is like low transfer efficiency and low flame retarded property, less surface finish, and these are adhesive to the water and the fire, and also like they are not the dust proof. So these advanced techniques for the nano paintings, you can see how it impacts. Like this is the A section is the conventional one. So you can see the binders which is in orange, and the cross linker agent it's in the red of the conventional paint. This is the conventional paint, and then you come to the nano coatings with the advanced materials. So you can see the binders having high elasticity. The yellow part, there's a high elasticity, and inorganic nanoparticle are strongly, like the blue ones are strongly tied up. So these linking give them high elasticity and high strength. And this is tightly packed. So this can be also scratch resistant. So for the scratch resistant, one of my researcher colleague had also did one experiment. They used aluminum nanoparticles here, and they use very less percent, 0.2 to 2.2 weight% of the aluminum nanoparticles in the weight in the nano paint, and they found that more the concentration is increased here till 2.2%, and they get very good scratch resistance till high. So if we use advanced materials for nano coatings, that can be very useful, which can be summarized in the next slide. So here you can see that the CNT is used for making it water resistant. So this is the metal surface for the nano coach, and there's CNT has been used for the nano coating, and is totally water droplet resistant. So this advanced nanomaterial nano coating can give you anti-corrosion, hydrophobic, improved mechanical properties, and scratch abrasion resistant also. And there can be it can be also inflammable. There can be some materials can be added which can help them not getting burned so easily. So we should step ahead further to go more in the direction of advancement in the nano paintings. So third point which I was to wanted to discuss is like now few of the companies are moving towards the advancement in the trains for the hydrogen fuel cells. So there is also one company in 2016, I think French-based company Alstom has developed a first hydrogen-powered train called Coradia Island. So what happened with these hydrogen-based fuel cells? Like hydrogen needs lots of spaces to store. Of course, this is like really eco-friendly. But when the hydrogen and water are thrown on the cathode and anode, the electricity is being dispersed, which causes train to move. But again, and it is really zero emission. But hydrogen requires lots of spaces to store. 1 kg of hydrogen fuels power 100 kilometers, but it requires 11,000 liter tank to store that 1 kg of hydrogen, which is like 2 big tanks are required. So, and it requires at least 700 bar, like pressure should be 700 bar to compress those hydrogen for 500 kilometer power. Like if a train has to run for the 500 kilometer, this much pressure has to be gained. So what our research colleagues has done in the hydrogen fuel cell is like they did the nano paintings to the engine, the internal part of the cell, and with the CNT and some other nanomaterials, and they worked as the hydrogen super sponges. And these super sponges, these are the ultra porous metal framework, and these have huge surface area, which stores a high quantity of hydrogen in a very small surface area. So by this, it can reduce our amount or the quantity of the liter tanks which required for the huge number of hydrogen can be restored in a very small tanks by the using hydrogen super sponges of CNT and some other nanomaterial. So there are some other application which can be worked. I have just explained 3 with the details, but there are more other applications which can be worked with the help of nanotechnology. Is the nano sensors. These are the excellent in strain and pressure detection. They are flexible. I have personally worked on many nano sensors and biosensors for the automobile sector in Fraunhofer and NAS, and they are really flexible and they have robust and longer life. They are very small and very small space taking. They are advanced material based tires. They are really wear resistant and they are eco friendly. Innovative photonic nano device. These photonic devices replace costly and bulky RF transmission, which we use nowadays in transportation system. For example, graphene-based transistor is good for power amplification, frequency multiplier, high carrier mobility, and unique ambipolar transport characteristics. So there can be efficient engine to reduction. These efficient engines using the nanomaterials, advanced nanomaterials, can reduce pollutant emissions, improve thermal conductivity of the engine. And for the safe and indoor environment in our transportation system, these nanomaterials or advanced biosensors can be used to clean our water, air purification, and also the water purification inside our trains and railways. In fact, in the aeroplanes. CNT and silver nanowire based inner fabrics are fire resistant too. And these are which I have shown you in the car figure also. They have ultra reflecting mirror and glass, which is hydrophobic, and advanced electrochromic and optical properties they have. So briefly, there is a comparison between the different transportation system, automobiles, aerospace, and marine, where these advancements are used for the nanomaterials. So they have used many nanoparticles for coating, for body parts, engines, tires, and interiors in automobiles, also for the aerospace and the marine part. And they got a very, very useful advantages over this by using these nanomaterials, which can be surely used in the railways also, which is yet to see many advancement in terms of nanomaterials in the railways. So here I want to conclude in a slide. So what are the impact of the nanomaterial in the automobile sector or the transportation sector, and also the demand? So here I have seen these few things which needs to be must do. They're like smart vehicles, environment-friendly nanomaterial, cost-effective nanomaterial, effective nanomaterial for safety, and extra protection against cracks. This is must to do. And what needs to do is like they are the things which needs to be really work on, which needs to be done in our automobile or transportation sector is like higher resolution imaging equipments, advanced sensing equipments, optimization of self-healing and self-cleaning, more durability, more efficient nanomaterials, and optimized nanotechnology for lighter weight. And there are few things which I have divided, which can be done by case study. Like or it can be done separately for railway, can be separately done for aeroplane, can be separately done for automobiles or marine. There is like to optimize which nano composite is good for insulation, or which nanofluids are good for engines, or for lightning, which can give a proper protection against the lightning. And there are a few things which I have like for the collaboration and the cooperation, and although also the selection of multifunctional nanomaterial, which needs to be more innovate and research right now. Um, Thank you from my end. If you want any question, please do ask me.
Thank you, Saurabh sir, for your insightful presentation. Thank you for sharing your thoughts on nanotechnology and urban transportation and enlightening us about the new opportunities for transportation infrastructure. Now I'll invite Dr. Amudan and Keshav Mishra to present their thoughts on this topic. Thank you, sir.
So Mahima, rather than presenting, would like to discuss more with Saurabh
Yeah.
about how the overall development could be take place in Indian scenario. Especially, I was very excited to understand about how the nanotechnology can help a better paint quality, which will not only make your a very shiny finish and very good finish, but also it reduce the overall air conditioning requirement inside the coaches. This is one of the major area. And second is the fire, because as we know, most of the Indian railways coaches or nearby coaches are very much prone to fire because of the type of fabric, because of the people of using their stuff inside as in storage, or they are carrying bag. So how actually nanomaterial or nanotechnology can help in this area, which is a very evident nowadays.
Yeah. So first thing, your first question was for the interior part, like the AC condition, or the you mean bacteria or things which are contained inside, or the viruses which are contained inside the coaches. So definitely there are many nanomaterial based biosensors which detects, not only detects these bacteria, they also purify them. They worked as air purifier, which is like mostly nowadays used in some of the automobiles, not yet has been experimented in the railways, but it can be. And for the fire part, there are many researchers, and already it has been implemented in the aero sector. The paint based on CNT and the silver nanowires they are really fire resistant for longer time, like for 15 minutes, 20 minutes, with different concentration. So I think 15-20 minutes is enough to evacuate a burning train or plane from making such a disastrous life. 15 to 20 minutes can save many lives, and they are really working CNT and silver nanowire based paints. But yet, Indian government has not worked yet on those types of nano paints. But still, some of the companies from France and UK is working on, which I have also mentioned one company from France, which they are working on those nano paints.
Thanks, Saurabh, for this answer. And is there any further real-time development happening in India about the nanotechnology and the
Yeah, so
material developed for these kind of applications?
Yeah, so like I mentioned, they are already Indian government are working on the world's lightest coach. Like we have already LHB, which is the lightest coach, but Indian government is also working on the most lighter coaches, which will be mostly based on ASHT. These types of material are used to manufacture the aeroplanes, the most lighter one. So Indian government are already working on these types of manufacturing plans.
Great to know about this, and we are also looking some of the advanced sensor who can detect like early warnings, which will not only prevent the accident, but also the asset life and the asset to be monitored, to be maintained for the longer period of time.
Of course, like if you see in the advanced automobiles, which I was working on the automobile sensors. They detect things from really far, and they are really flexible. And we have in the advanced automobiles, we have that airbag systems which are still lacking in our railway side. So now if you see Tesla, they have airbags in their mirror too, or the glasses too, and we are yet to find even in our seats. In If you see the current advancement, so definitely there are lots of a bracket to develop in terms of railways.
So how BizSpan can help us to get it more information to develop such kind of product or
So
the research oriented programs on it?
yeah. So personally, like I'm one of the person who has been working throughout my life on this advancement of nanomaterials. So we have a client also who is probably the only company in India who develops advanced materials like silver nanowires, CNT, and all. So we have a complete team of technical people who can help Indian government or the companies, manufacturing companies, giving technical consultancy regarding the advancement or the things which they can bring from the Germany or more new innovation for the advancement of technologies in their manufacturing units.
So there is one question from Mr. Shusil that what about the undercarriage fire of rolling stock?
Hmm.
Except water sprinkle, does a nano film can prevent the fire?
So nanofilm can't prevent the fire like by giving the sprinkling of water, but there will be early detection, and also the nanofilms have the like CNT, which I told you, CNT and silver nanowires coatings can make the automobile more inflammable, like that can't so easily burn. The coaches and everything, the rolling stocks can't burn so easily. It will take 15-20 minutes to burn it.
So how commercially it will be feasible to implement for the private player? Because yes, the government may have a mandate after a few years, a few months later,
Mhm.
to implement or to take it as a mandatory. But the private player or the manufacturer, how they are looking for the advancement in this segment?
So the private players are already working on this. Like if you see Delhi Metro or any metro, they have very advanced system of a system for safety and safety as compared to the Indian railways. So if government is allowing them, they are ready to procure the technology from. I think they are ready to procure the technology from the outside, or more ready for R&D and innovation to bring these systems as soon as possible.
Thank you, Saurabh. It's really very informative for not only the panelists but also for the participants because these are the emerging sector and being a rolling stock or even a urban transport prone area, it will definitely help in the future for the user as well as the manufacturer and the developer. So I would like to request Dr. Balwan to have any specific question towards Saurabh so that will be good for us to understand more and more.
Yes, sir. Thank you. Good afternoon.
Yeah.
Good afternoon to everyone present. The program today threw light on how nanotechnology can be leveraged into smart urban transportation. This idea in itself is intriguing and opens a whole lot of possibility in terms of innovation. There is so much information and technological advances happening every day, and meets up like these are great way to bring knowledge into everyone's reach. Saurabh Choudhary spoke elaborately on the topic and he conveyed it in a crisp manner. Adding to what we heard, I must say I am really fascinated with the concept of getting tiny. Already the medical field is benefiting greatly from microbots and nanobots to perform surgeries. In tomorrow's world, there will be no more open surgeries. In fact, there will be no need for physician for as a small and big automated robots will constantly monitor us and repair us whenever needed. Coming back to our topic, nanotechnology in transport, we see how materials and their physical capability in terms of its strength and capacity to withstand pressure, heat, etc. increases greatly when they are made up of nanoparticles. This paves way for super light cars and buses. Airplanes can weigh less than passengers traveling inside it. Fuel efficiency can be doubled or even tripled. Nanotechnology in batteries and cell production decrease charging times and increase battery capacities. This means that the world has finally found some hope in renewable energy source. The only thing we that we cannot bring into the nano scale is the vehicle itself, except for nanocar. Like I thank to Tata Motors. Every other instrument used to build it can directly or indirectly benefit from having those 10 to the power of minus 9 particles in their architecture. I hope more people get into the field and bring a lot of changes. With this, I want to thank the urban transport team that organized this event today. Thanks a lot for the opportunity to be in the panel. It was an enlightening experience. Have a great day, all. I think almost.
Thank you, everyone. Thank you, Team Urban Transport, and thank you, every guest. Thanks a lot.
Thanks, Saurabh and Dr. Balwan. Really a very good session for us. So over to you, Mahima.
That was a very insightful discussion, sir. We are grateful to all of our guests for the time and efforts they took to share their thoughts. So, a big thank you for taking your precious time to attend this webinar on Railway and Metro Infrastructure 2021. We are greatly appreciate your attendance and we look forward to getting connected with you soon in the second half of today's session. I request you to share your feedback in the chat box. Thank you for all joining.